Hi students, today in this video I am going to solve the numericals based on lecture 1 to lecture 5. This is the video 6 from chapter 2, and before going to solve the numericals you need to follow these 4 steps. Step 1 is first we need to read and understand the problem carefully. Step 2 is we need to find the given data and the quantity which is to be calculated. And the third one is we need to find the exact relationship between the known and unknown quantities are there in the problem. And step 4 is after calculating the result, we must write the result with a proper unit. So by writing the different unit which is not a proper one, then you will lose the marks. That's why result with a proper unit must be written. These 4 steps must be followed while solving the numericals. So, we'll start now with the problem number 1. If 10 power 9 electrons move out of a body to another body in every second, how much time is required to get a total charge of 1 coulomb on the other body? So, if 10 power 9 electrons move out of a body to another body in every second, then how much time is required to get a total charge of 1 coulomb on the other body? This is the problem, and given data in this, 10 power 9 electrons are transferred from one body to another body in every second. Then we need to find how much time is required to get a charge of how much? 1 coulomb on the other body. So, number of electrons move out of a body, or number of electrons are transferred from one body to another body in 1 second is equal to 10 power 9 electrons. Then suppose 10 power 9 electrons are transferred. So 1 electron transferred means 1.6 into 10 power minus 19 coulomb charge will be accumulated. Here how many electrons are transferred? 10 power 9 electrons. So total charge in 1 second. So charge given out in 1 second is equal to number of electrons transferred into charge of each electron. That is 1.6 into 10 power minus 10. How will be this 10 power minus 10? Here 10 power 9, here 10 power minus 19. Base is common. We can add the powers. 9 minus 19 is minus 10. So this is 1.6 into 10 power minus 10 coulomb. So this much charge we are getting in 1 second. In 1 second, how much charge we are getting? 1.6 into 10 power minus 10 coulomb. The time required to accumulate a charge of 1 coulomb, I am assuming that it is a T. So this much charge we are getting in 1 second. To get 1 coulomb, how much time is required? That is a T. So T is equal to charge to be get, that is a 1 coulomb divided by charge in 1 second. That gives the number of seconds required to get 1 coulomb. So 1 by 1.6 into 10 power minus 10. So 1 by 1.6 is nothing but 0.625 into this 10 power minus 10. If you write in the numerator, it will be 10 power 10. So 0.625 into 10 power 10 seconds. This 0.625 can be written like this, that is 6.25 into 10 power minus 1. Just adjust the decimal point. So 6.25 into 10 power minus 1 into 10 power 10 already is there. So 10 into 10 here, base are same now. So we can add the powers. 10 power minus 1 into 10 power 10 will be 10 power minus 1 plus 10. So minus 1 plus 10 is equal to 9. So 6.25 into 10 power 9 seconds. So what is the time here? 6.25 into 10 power 9 seconds. So this many seconds we will get to get how much? 1 coulomb charge. So these many seconds are required to get 1 coulomb charge. Next, these seconds can be written in terms of year. Just divided by total number of seconds these with the help of what is that? Number of seconds in 1 year. So number of seconds in 1 year means 365 days into 24 hours into 60 minutes into 60 seconds. These are the number of seconds in 1 year. Total number of seconds divided by number of seconds in 1 year, that gives the number of years required to get the 1 coulomb charge. That is equal to 198 years. So T is equal to approximately we can write 200 years. This much time is required to get 1 coulomb charge if 10 power 9 electrons are transferred from one body to another body. So what's the time required here? 198 years, or approximately 200 years. Next, problem number 2. How much positive and negative charge is there in a cup of water? We need to find total positive charge and total negative charge in a cup of water. Assuming that mass of 1 cup of water small m is equal to 250 grams. So what is the mass of 1 cup of water? 250 grams. Molecular mass of water capital M is equal to 18 grams. Then how to get the total positive charge and total negative charge in a cup of water? For this, first we need to get the number of electrons or number of protons in a cup of water. Okay. If you know the number of charges, we can get positive charge and negative charge. If you know the number of positive charge particles, we can get positive charge. If you know the number of negatively charged particles, we can get a negative charge. So we need to get total number of electrons in a cup of water and the total number of protons in a cup of water. To get the total number of electrons and protons in a cup of water, first we should know the number of molecules in a cup of water. That's why first I calculated number of molecules in 1 cup of water is equal to small m, means mass of water divided by molecular mass of water into Avogadro number. That gives 250 by 18 into 6.02 into 10 power 23. This is the number of water molecules in a cup of water. By knowing the number of water molecules in a cup of water, we can get total number of electrons and protons in a cup of water. Each water molecule contains 2 hydrogen and 1 oxygen. So 1 hydrogen will have 1 electron. So 2 hydrogens will give 2 electrons and 1 oxygen will give 8 electrons. So total number of electrons in 1 molecule only 10. Total number of protons in 1 molecule only 10. So number of electrons and the protons in a water molecule are same, that is 10 electrons and 10 protons. First I calculated number of water molecules in a cup of water. Next I calculated number of electrons and protons in 1 molecule only. With help of these two, we can get a total number of electrons in a cup of water. That is number of molecules in a cup of water into number of electrons or protons in 1 molecule. So number of molecules into number of electrons in 1 molecule gives the total number of electrons or total number of protons in a cup of water. So here magnitude we are taking total negative charge magnitude is equal to total positive charge magnitude, since both are having equal number of charge particles. So here number of electrons and number of protons are same. So total number of electrons or protons in 1 cup of water is this much. So this is the total number of electrons or protons in 1 cup of water into charge of 1 electron or proton, its magnitude 1.6 into 10 power minus 19. That gives the 1.34 into 10 power 7 coulomb. This is the total positive charge or total negative charge magnitude in a cup of water. For this problem, first I calculated number of molecules in 1 cup of water, number of electrons in 1 molecule. With help of both, I calculated number of electrons or protons in a cup of water. By knowing the number, we just multiply with the charge value, then we will get total number of positive charge and negative charge magnitude. That is a 1.34 into 10 power 7 coulomb. This is the magnitude of negative charge, that is equals to the magnitude of positive charge. Next, problem number 3. Calculate the ratio of electric and gravitational force between 2 protons. So we need to get the ratio of electric force and gravitational force between 2 protons. So first we need to get the electric force between two protons, then after that gravitational force between two protons, then getting the ratio of both, that is only the answer. So mass of proton they have given, that is 1.672 into 10 power minus 27 kilograms, and charge of proton is 1.6 into 10 power minus 19 coulomb. This is the given data. So Q1, two protons now. So first proton charge is Q1, second proton charge is Q2. First proton mass is M1, second proton mass is M2. So Q1 is equal to 1.6 into 10 power minus 19 coulomb. Q2 is equal to same value since both are having same charge, since both are protons only. So Q2 is equal to 1.6 into 10 power minus 19 coulomb. Mass of first proton M1 is equal to 1.672 into 10 power minus 27 kilograms, and the mass of second proton is same, that is 1.672 into 10 power minus 27 kilograms. So from Coulomb's law, we can get the electric force between two charged particles, that is Fe is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by d square. Here 1 by 4 pi epsilon naught value 9 into 10 power 9 into Q1 is 1.6 into 10 power minus 19 into Q2 is equal to 1.6 into 10 power minus 19 divided by, here distance is not given, so distance assuming that d, that's it is equal to d square. So this is equal to 23.04 into 10 power minus 29 divided by d square. This is the electric force between two charged particles, that is protons. Now gravitational force, since both are having masses, we will get gravitational force also. From first year chapter, gravitation, from universal law of gravitation, we will get the gravitational force between two mass particles or mass objects. So we have G is equal to, it's capital G into M1 into M2 divided by d square. Here G, capital G is the universal gravitational constant. Its value is 6.67 into 10 power minus 11. M1, mass of first proton, and into M2, mass of second proton divided by d square. Here distance is not given, assuming that it is a d. That is equal to 18.64 into 10 power minus 65 divided by d square. This is the gravitational force between two protons. This is the electric force between two protons. So we got both electric and the gravitational forces. Just get the ratio of both. That is electric force divided by gravitational force. They are asking a ratio of electric and gravitational. So electric divided by gravitational is equal to 23.04 into 10 power minus 29 divided by d square divided by 18.64 into 10 power minus 65 divided by d square. Here d square get cancelled. Remaining one, 23.04 divided by 18.64 into 10 power minus 29 divided by 10 power minus 65 is equal to 1.23 into 10 power 36. So after getting the ratio of this, we will get 1.23 into 10 power 36. So electric force divided by gravitational force, the ratio of electric and the gravitational force between two protons is 1.23 into 10 power 36. Next, problem number 4. Two charges 4 microcoulomb and 1 microcoulomb are placed at a distance of 10 centimeter. Where should a third charge be placed between them so that it does not experience any force? Here Q1 charge is 4 microcoulomb, Q2 charge is 1 microcoulomb are placed at a distance of d. Then where should be placed third charge, say it is small q, in between them so that net force is 0 on small q. So Q1 is equal to how much charge? 4 microcoulomb, that is 4 into 10 power minus 6 coulomb. Micro is 10 power minus 6. Q2 is equal to 1 microcoulomb, that is equal to 1 into 10 power minus 6 coulomb. Here micro is 10 power minus 6. Then distance between them is d is equal to 10 centimeters. And we should find the where should be placed the third charge in between them. So let third charge q, any value you can take, let third charge is small q, is placed at a distance of how much? X from q1. So third charge, I am assuming that small q is placed at a distance of small x from q1. So from q1 it is a distance of x, from q2 it is a distance of d minus x. So Net force on this small q is equal to 0. Net force on this 0. When net force is 0, force between q1 and q must be balanced by the force between q2 and q. So these two forces should be equal in magnitude. That's why force between q1 and q2, so force between q1 and q must be equals to the force between q2 and q. Okay, so force between q1 and q should be equal to the force between q2 and q. So force between q1 and q is 1 by 4 pi epsilon naught q1 into q divided by x square. This is from Coulomb's law. And force between q2 and q is 1 by 4 pi epsilon naught q2 into q divided by d minus x whole square. Here small q get cancelled. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught also get cancelled. Remaining one is q1 by x square is equal to q2 by d minus x whole square. Here q1 is 4 into 10 power minus 6 divided by x square is equal to q2 value 1 into 10 power minus 6 divided by d minus x whole square. Here 10 power minus 6, here 10 power minus 6 both get cancelled. Remaining one is 4 by x square is equal to 1 by d minus x whole square. Here 4 I can write 2 square. 2 square by x square is equal to 1 divided by d is equal to 10. So 10 minus x whole square. Now 2 by x, here 2 square by x square, a power m divided by b power m means a by b whole power m. With that formula, 2 square by x square is equal to 2 by x whole square is equal to 1 by 10 minus x whole square. Square get cancelled. Remaining one is 2 by x is equal to 1 by 10 minus x. Do the cross multiplication here. That is 2 into 10 minus x is equal to x into 1. X into 1 is x. That is 2 into 10, 20 minus 2 into x, 2x, 20 minus 2x is equal to x. Send this minus 2x, that side will become plus. So 20 is equal to 3x. 3x is equal to 20. X is equal to 20 by 3 centimeter. This is from Q1. We assume that Q charge must be placed in the distance of x from Q1. So that's why x is the distance from Q1. X is equal to 20 by 3 centimeters from Q1. If they want to get what is that from Q2, just do the d minus x, we will get the distance from Q2. So from Q2, d minus x, 10 minus 20 by 3 is equal to 10 by 3 centimeters. This is from Q1 and this is from Q2. If they ask from Q2, get it this one. If they ask from Q1, up to here is enough. This is the distance of third charge should be placed. So the net force on that is equal to 0. How much? 20 by 3 centimeters. Next. Problem number 5. What is the force between two small charge spheres having charges of 2 into 10 power minus 7 coulomb and 3 into 10 power minus 7 coulomb placed 30 centimeters apart in air? This is the problem. We need to get the force between two charged small spheres having charges 2 into 10 power minus 7 coulomb and 3 into 10 power minus 7 coulomb placed 30 centimeter apart in here. First find the given data, you people only. So here charge Q1 is there, Q2 is there, distance D is there. So Q1 is equal to 2 into 10 power minus 7 coulomb, Q2 is equal to 3 into 10 power minus 7 coulomb, distance D is equal to 30 centimeter, that is equal to 0.3 meters, that is 3 into 10 power minus 1 meters. By formula, F is equal to, this is a force between two charges formula, F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by B square. 1 by 4 pi epsilon naught value is 9 into 10 power 9 into Q1 is 2 into 10 power minus 7 into Q2 is 3 into 10 power minus 7 divided by 3 into 10 power minus 1 whole square. So here 9 into 2 into 3 is 54. Here 10 power minus 7 into 10 power minus 7, 10 power minus 14. Here 10 power 9 into 10 power minus 14. Since base is common, we can add the powers. That is 54 into 10 power 9 minus 7 minus 7, that is 9 minus 14 divided by 3 square is equal to 9. 10 power minus 1 whole square is 10 power. And this is for both. We need to apply the square. That's why 3 square is equal to 9. 10 power minus 1 whole square is equal to 10 power minus 2. 54 by 9 is equal to 6. 9 1 ja, 9 6 ja, 6 into 10 power. 9 minus 14 is minus 5 into this 10 power minus 2. We can write like a 10 power plus 2 after taking into the numerator. This is 10 power 2. So 6 into 10 power. Here minus 5, here 2. So here base is same, we can add the powers. Minus 5 plus 2, minus 5 plus 2 is equal to minus 3. That is 6 into 10 power minus 3 newtons. So what is the force between these two small spheres having charge, this one and this one, separated by 30 centimeter distance? 6 into 10 power minus 3 newtons. Since the both are positive charges, what type of force is there? This is a repulsive force between these two charges. How much? 6 into 10 power minus 3 newtons. Next, problem number 6. This is the last problem for this video. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. So we need to find the distance between these two spheres and we need to find the force on second sphere due to first. This is the given problem. First we need to find the given data. So here first one is one small sphere is there having charge 0.4 microcoulomb. Another small sphere is there having charge 0.8 minus 0.8 microcoulomb. This small sphere exerting force on this small sphere. So this is the first one and this is the second one. Got it? This is the one first sphere having charge this. This is the one second small sphere having charge this. So this second sphere exerted force on first sphere. How much? 0.2 Newton. This is the meaning of first two lines. So what is the meaning of first two lines? A small sphere having charge minus 0.8 microcoulomb exerted force on another small sphere having charge 0.4 microcoulomb. How much? 0.2 Newton. So that's right. Q1 is equal to 0.4 microcoulomb. Micro means 10 power minus 6. So 0.4 into 10 power minus 6, that is equal to 0.4. We can write 4 into 10 power minus 1. So 4 into 10 power minus 1 into 10 power minus 6. So base is common. We can add the powers. Minus 1 minus 6 is equal to minus 7. So it is equal to 4 into 10 power minus 7 coulomb. And Q2 is minus 0.8 microcoulomb. That is minus 0.8 into 10 power minus 6. Further we can write like this. Minus 8 into 10 power minus 7 coulomb. This is the Q1 charge, 4 into 10 power minus 7 coulomb. This is the Q2 charge, minus 8 into 10 power minus 7 coulomb. So, force on, from problem, force on first sphere due to second sphere F12 is equal to 0.2 Newton. This is the given data. We need to find distance between these two small spheres and force on second sphere due to first. So F12 is equal to, from Coulomb's law, a force between two bodies or two charged bodies having charge Q1 and Q2 separated by distance d. F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by d square. So F is given, Q1, Q2 also given, 1 by 4 pi epsilon naught known value. We need to get d square. So take separate. What is the d square? D square is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by F12. 1 by 4 pi epsilon naught value is 9 into 10 power 9 into Q1 is 4 into 10 power minus 7. So 4 into 10 power minus 7 into Q2 is 8 into 10 power minus 7 divided by F12 value 0.2. So 9 into 4 into 8 is equal to 288. 288 into 10 power 9 into 10 power minus 7 into 10 power minus 7. Since base is common, we can add the powers. 9 minus 7 minus 7. Minus 7 minus 7 minus 14. This is 10 power 9 minus 14 divided by 0.2. We can write 2 into 10 power minus 1. This is equal to 144 divided by 10 power minus 1 into 10 power minus 5. So 288 by 2 is 144. 144 into 10 power minus 5 divided by 10 power minus 1. This 10 power minus 1 we can write like a 10 power 1 by writing the numerator. So d square is equal to 144 into 10 power minus 5 into 10 power 1. Here base is same. We can add again powers. Minus 5 plus 1. Minus 5 plus 1 is minus 4. So d square is equal to 144 into 10 power minus 4. D is equal to square root of 144 into 10 power minus 4. So square root of 144 is 12. 12 into square root of 10 power minus 4 is 10 power minus 2. So 12 into 10 power minus 2 meter, that is equal to 12 centimeters. So what is the distance between two small spheres? 12 centimeters. First one is over. Second one is force is mutual. So here force exerted by second one on first one is equal to force exerted by first one on second one. Both will be same. So force is mutual. So the same force of 0.2 Newton acts on the second sphere due to first sphere. So force on second one due to first, F21 is equal to 0.2 Newton. So distance calculated and force on second sphere due to first also calculated.